Our next presenter is Sebastian Dick. He is with A&W Software in Germany. Sebastian Dick brings 23 years of expertise in the glass industry. Since joining A&W Software in 2002, he has implemented A&W's software solutions worldwide. In 2018, he became product owner, launching the innovative A&W Smart Companion app and later overseeing A&W Smart Factory. By 2021, Sebastian established the innovations department at A&W Clarity, where he partners closely with A&W customers and to design cutting-edge solutions that drive industry progress. Today, Sebastian will be speaking on digital twin, visualize, change, and simulate your own glass laboratory. Please, let's welcome Sebastian Dick.
Thank you. All right. Hello, everyone. So I want to speak a little bit about digital twins, and obviously that's quite a strange topic for a software company as ours, as we are mainly focused into ERP and MES solutions, which is not typically the operation field of a digital twin. So that might surprise some of you. If you don't know A&W, we are quite a big player in the software game for the glass industry with 8 subsidiaries around the world and 1,100 customers. And as you can see, with 200 employees and 30% out of it working in R&D, we are quite heavy R&D focused. Also, we are owned in the Constellation Software Corporation, so we are part of that. So first look into the digital twin, and to catch everyone up, because as I said, it's a bit strange topic for our operation field, there's multiple digital twins available, or types, let's say. So there's something like a component twin, an asset twin, system twin, and process twin. And when we are looking deeper on that level, let's say it's a system twin, that could be an entire machine. So you get data from the machine, like energy consumption or whatever, and which parts are moving, what glass could go or should go to the machines, which kind of process needs to be done at that machine. And that is a level of a system twin, let's say. And the next level, we are digging deeper, that is an asset twin. An asset twin could be a part of a machine. So in that case, for example, a spindle of a CNC machine, and that provides, again, data to the system twin above, like feed rate, spindle speed, how fast is that thing turning, and so on. So that is all machine data that is relevant for the machine itself. But again, speaking about the software part, not really for us. The next level is a component twin. So, for example, you have that drill insert in that CNC machine. It has certain parameters and stuff like that. That's rarely a twin that is used in our industry from my perspective. But at the end, it's relevant for our software, so I need to know that drill insert is available in the machine, so that we can execute drill holes in a 20 mil diameter and stuff like that. So that is a component twin level. But what's more interesting for us, and where I want to speak about, and also that catch-up is needed, I would say, is that process twin. And that's actually the level of your shop floor organization. So when it's about what needs to be cut when it needs to get delivered, which processes are in between, and which route is taken across the shop floor. And that is that level of a process twin, or you could also call it a macro level here. The other thing is simulation we need to look into really short. And here we can take that component again. So simulation is needed, for example, for a component to provide you with parameters for that drill insert. So how fast can it spin, and what diameters, and what is the feed rate it can move, and so on. And when it's starting to operate in a critical level. And on a system level simulation, that could be even an Excel. So that can be quite simple simulations or really advanced stuff where you're hiring a third-party consultancy and looking into throughput calculations and so on. You want to drive a new product mix in your site. And that is typical simulations you can do with external systems like that. So planning new machine layouts and stuff like things. Something we are doing right now in simulation is when it's about machine connectors. So that is speaking with a CNC machine, for example. We know here in that example with that screenshot which drill inserts are fitted to the machine, what is available. Can that sheet, which has been scanned in that solution, be executed on the machine by availability of tools and so on? And there's also something like a path calculation. Yeah? So if I drive, let's say, that cutout here with a 17 mil insert, is that possible or not? And then you can see directly in simulation, no, there's not enough room to turn that drill head or that drill insert. We would say we need an 18 mil, and the driver suggests that. So we are just fitting it, and that process can be executed. So that is typical simulations we are doing in our driver systems for different machine partners. But as I said, where I want mainly to speak about is that level of shop floor organization, so that process twin level. And when we are looking into the product portfolio we are doing, as I said, it's mainly that enterprise resource planning, so the ERP solutions, or the manufacturing execution systems, the MES, so the production part. What we are looking into mainly right now is the MES, so the organization of that shop floor. What needs to be driven through the shop floor, which routes, on which machine, and so on. And there needs to be different calculations or strategies, because if you are moving something on a conveyor, like here in a CNC, you have something like a FIFO logic, and if you're going for a rack, that's a different story. Then you can have half racks, or you can have sorting systems and stuff like that. So that level quite scales on the shop floor, where the MES is organization, that routing, or typical MES is organization. Your planning data, what needs to be produced, when and where. And that is that target data level. So the simulation part of the MES. And that is something like, I've explained already, the route or the start time, when that sheet needs to be moved to a certain machine to really be capable to finish that product. So there's also transition times and things like that. And the total lead times for the delivery. So all that is provided in MES, typically, simulation part. And then comes the digital twin part of that MES. And that, I would say, is close to a tracking system, which most systems should provide. So that is tracking data like, hey, I have produced that sheet right now at that time at the CNC. So it's ready, it can go to the furnace, for example. So that is checking that route, if all that was possible. So we have typical interfaces for that, some registration points or whatever you are setting up. Employees can scan sheets and address them to certain positions, and we know, okay, process is done. Or if driver is reporting, no, I don't have that drill head, but I do all the other operations and it was at that machine, but maybe some process is missing. And all that ends up into some digitized shop floor layout, typically organized like your real production looks like. So you have some number areas for cutting department, something for the edge stuff, furnace and so on. And when we are looking at that layout here, we also see there are sorter levels in between. That is actually our test environment we are using for QA approaches and so on with our software and compare software. That's called Class Lab. And what you see here is really just a layout of a customer and put together in some Excel or whatever, some paint tool. So nothing generated from the software. Now comes the interesting part. I call that the shadow twin. So that is some word creation in here. And that is maybe have a new approach on that stuff. But a short catch up here when it's about ERP and MES projects. I have done quite some in my 18 years around the globe, and there's one thing for sure, every one of you guys works different, so there is no standard or whatever, and you don't have to compare Australia or Austria even, that far distance. You can go to the same company down here in the right corner, that greenish one, so let's say a color is representing a customer, that's all the same customer. but every site works different. So one just ships the stuff, the next one has a completely manual organization, one is using a sorting system, next one is highly automated, and so on. So there is very much strategies how to drive the organization. And if it's coming down to reports and what's the focus, I'm completely focused on yield, or I'm completely focused on dense packing for deliveries and so on. There's so much different strategies out there. It's quite a pain to set up a product to fulfill that needs. And that is, just to bring you all on the same level, we're coming back to that later. When you're running a simulation, you are doing all that work again in a third system next to it. So let's have a look into planning versus tracking data. And you see that layout has changed a little bit. So that is actually from one of our UIs. And it's a new way how we are connecting the shop floor environment. But let's see how MES is organizing your shop floor. So we have a route through the production, like I've explained. We have some planned times for that machines. And we all know how good a plan is. There's something called reality that kicks in at some point. So for example, we have here a hotspot at the edge 2. So it was planned for 9 o'clock at that machine. But as you see with the red color, maybe there is some problem at that machine and it won't happen. So in reality, we also see that time differs. So they are not that nice rounded 8 o'clock, 9 o'clock. So it's 13:26 and even milliseconds behind that. And that's for all set states. And what you are doing in reality is in any MES, I would say, when it comes to tracking, you tell the system, hey, I have cutted that class. Then we know that time. We also know, okay, we have cut it with some delay here over 4 hours. And then it goes to the sorter and so on. And at one point, we take actions from that. So we take an alternative round. Maybe we call someone and fire up the second furnace. And we can still keep that timeline. But all requires manual organization. And what we are doing different with our MES here is we have a so-called service-orientated architecture, our SOA. That's an ice grid. And all what you see here on the left is services. So we are not running any static product front-end program with business logic integrated. So everything is available as our own service. And in that environment, it's also easy to replicate that services and scale that stuff as it's needed, let's say. And that gives us also possibilities to have optimization separate and the routing separated from that business logic. And we can go really on a quite high dynamic routing through production. What I mean with that is, let's see at the shop floor again, at that layout. We have again something that needs to be cut, or it's an IG we want to produce, so that's 3 sheets. And 2 sheets getting cut, and 1 is a good receipt. And the good receipt is influencing the cutting start. So as soon or as long as the stuff is not available, it doesn't make sense to cut it because it will just fill up our buffer and blocking us. So we are waiting till that stuff is goods received and it's available in the sorter. So we delay the cutting for the 2 off sheets. And as soon as they are available, we activate the cutting process and the stuff gets routed through the production. So you see that blue arrows was the first route we activated. And that is because that is a sheet that goes to the furnace. So we know, okay, furnace process time is longer at that case. So it's the first sheet we are starting. And as soon as it reaches sorter 3, it starts the other sheets and takes the purchase part with us over the bypass road. So that is really on a dynamic level, let's say. And then when the sheets are available, we're starting the cutting process, and all the sheets are moved through the IG line. So we can wait till all parts are complete. So that means a full output group for a packing optimized rack or something. Or you can even say, no, I want to start that stuff, even if everything is not available yet, but we want to deliver to the customer. So and the system is reacting in real time. And that is, possible by that service-orientated architecture. You can compare it to a marble run. So we have that layout, we know where which sheet goes and so on, and that is possible in or with that architecture. And in that SOA, it's possible to work in a container environment, so that is some orchestration, which I also explained. We can replicate services, and it's maybe not just one service, maybe we can just replicate the entire site. So you have seen that layout here, we have described some of the flows, and let's say that is our live environment you are using with our MES. So there are 500 orders released, system has done some calculations, some routing, whose stuff goes through the shop floor. But what would be the case if I buy a second CNC line or another furnace and so on? So where is my bottlenecks? And that's a moment where we are doing a snapshot. So we are just putting that layer on top, that's our live layer, and we introduce a snapshot to that environment. So we have a second MES on replicated services available. So that is a virtual environment. And with simulation, if you're doing third-party simulation, you must always maintain that system. That's master data, routes or whatever, and it has different capacities or different organizations and configurations like your live environment. So there's always a difference. With that shadow twin technology, you have the possibility to, in real time, compare that layout with your live layout. So that means our 500 orders are going through that shop floor. Well, so we have seen that routing, and we have seen the CNC is on its fully capacity. So it's 100% filled. It's only 250 sheets, 500 are released. So we can only go for next day delivery with 250 sheets. In the virtual environment, we have added another CNC machine. And with that CNC machine, it's possible to release the other 250 orders, have a fully capacity lock on the second CNC. We just add another shift for the furnace 2, because that is possible right now. Same for the heat soak. And at the end, we reach our target to have a next day delivery of that 500 pieces. Of course, that's a really simple example here, just to show you how the technology works and what's going on. But that is only possible by that service-orientated architecture and that orchestration of services, so that we can replicate them and create simulation instances. So why should I do that? Or what is the interesting part for it? So a customer wants typically to identify bottlenecks, so speed up the production, increase it, or maybe you want to create new products, you want to extend your portfolio on site. So which machines are needed, or what bottlenecks could occur when we are extending our product mix. And the other is even a greenfield planning operation. So you could even manipulate that second layer to extend like it's behaving like a complete new site. And again, you're running the test orders from your live system, so you don't need to represent them to that environment. It's all there. So the benefits are clear here. So you don't need to configure something, have second consultancies going on, create new knowledge with your employees and so on, because they all know that system already. So it's all in the same environment. And that is a key strength, let's say, of that product or that technology. And what you can see on the right side, we are also working at the moment on some visualization of that things, and that is also the presentation title, that's the class lab. And that is one of the next steps of the product, to even have some animated shop floor and you see what's going on out there. Not in real time, but you get an idea which machines are blocking and what's going on outside your environment. If you have any questions to that, please come up with it. You can also ask me later on. That's not a problem. So I'm available the entire show. Thanks very much.